Those lectures got lost, but it's on now. So let's talk about types in Go. And this is slide deck 17. So we're 20 away from creating a photo blog. Not that far to go. And we could define our own types. So we could have user-defined types. I'm just going to change the color of this to reflect the color scheme I was trying to stick with. And we already saw this code when looking at structs. But right here, we're creating our own type. And the type that we're creating is a type person. And it's unexported, which means it won't be visible outside this package since person is lowercase, right? But, you know, I mean, take a look at that, right? Person is a type. And the type of person is a struct. So the underlying type of person is a struct. And then we could, you know, create people from person. And when we do that, we are creating values of the type person. So notice I'm not saying an instance, though, you know, I think that word would get used, and I've like 80% certainty on this. But we don't talk about objects or instances. We talk about types and values, right? I'm creating a value of type person, and I'm assigning it to the variable p1. So that's kind of cool. So user-defined types, another example. My sentence string. Okay, so there's another user-defined type. My sentence is a type. That's a type. And it's of the underlying type is string. All right, so I could have var message my sentence, hello world. So there I have a value, and the value is hello world. It's been assigned to the variable message, and the variable message is of type my sentence. And if I print the type of message, I see that the type is my sentence. So we're creating our own types, which is really different. It's not like object-oriented programming, right? Where all the types are already defined. I don't know, maybe some languages you could do this. But to me, this seems pretty novel. And we wouldn't necessarily ever do this. Don't create an underlying type just to alias it, right? Like, oh, I could just use string here. So this is only to illustrate that we could create user-defined types. This is strictly for illustration. You wouldn't ever really do this in production code unless for some reason you needed to attach a method to a type, right? And so, you know, there's some reason you're like, okay, I got to attach a method to that. Then you would do that maybe. But, you know, don't create types just as an alias. That's just going to make things confusing. But interesting, we could create a type, my sentence, where the underlying type is a string. And we could use conversion. Right? So here, the type, first time I print the type, it's my sentence, and I can convert that to its underlying type, which is a string, which makes sense, right? We know it. We know that my sentence's underlying type is a string, but the compiler sees that as its own distinct type. And but it also understands that the underlying type is string, but we have to explicitly convert it to string if we wanted to convert it to its underlying type. So conversion is different than assertion, right? So assertion is strictly for interfaces. And here I'm trying to assert that message is a string. Message is of type my sentence, and the underlying type of my sentence is string. And so I'm trying to assert, hey, but assertion is only for interfaces. And you can see that in there, non-interface type, my sentence on left. So the type system in Go. We have pre-declared versus composite types. Golang by default includes several pre-declared built-in primitive types. Boolean, numeric, string. Primitive, and Carson, I'd be interested in hearing your input on this, but my understanding of primitive is like it's not mutable, right?
I don't know about that.
I know.
So
these are like those things which are like, I just want to make sure I'm being precise with the language to talk about computer languages, but that's my understanding of primitive, is that they're not mutable. You can't change them.
yeah, I think you're right, yeah.
You know, like you can't change a string. You get a whole new string if you change a string. It's not like you altered that one variable or memory address or whatever.
Another thing is like there could be a difference between reference types and
Right.
that's what comes to my mind, but I don't know.
Pre-declared types are used to construct other composite types. So composite types, like a struct, is a composite of a bunch of booleans, numerics, and strings, or slices, or arrays, right? Yeah, and then another way we talk about types sometimes is reference. So string is a string a reference type? It's referenced as an underlying array, so yeah. And then a slice references an underlying array. A pointer, I think, is by definition a reference. So I'm still getting clear on some of this stuff myself, but anyhow, we know Boolean, numeric, string, array, struct, pointer, slice, map, channel. Go is statically typed. So statically typed means that the type is checked by the compiler at compile time. A language is statically typed if the type of the variable is known at compile time. This in practice means that you as a programmer must specify what type each variable is. Right? You have to say it's this type. The main advantage is that all kinds of checking can be done by the compiler, and therefore a lot of stupid bugs are caught at a very early stage. A language is dynamically typed if the type of a variable is interpreted at runtime. This means that you as a programmer can write a little quicker because you do not have to specify the type every time. So statically typed is actually a cleaner way to program, and it catches errors. So when you talk about type provides the compiler two pieces of information: size and representation. Size and representation. So size is how much memory to allocate, and representation is what does the memory represent. So think about like, uint8 or int32 or int64. The representation is it's an int, and the size is right there. But that's, in the name. Sometimes it's not in the name, but that's what we're talking about when we talk about type. It's size and representation. What is the size, and what are we representing here with this type? Representing a string, an int, a float, and how much size are we taking up? Most of the time we just think about representation. Oh, it's a string, it's a float, it's an int, it's bool, right? But size is the other thing that's important to think about when you're talking about type. So type provides the compiler two pieces of information: size and representation. A value of type int64 requires 8 bytes of memory. So int64 requires 8 bytes of memory, which is 64 bits, and represents an integer value. A float 32 requires 4 bytes of memory, 32 bits, and represents a binary floating point number. A bool requires 1 byte of memory, 8 bits, and represents a Boolean value of true or false. Right? So interesting, right? Type and representation. Or type is size and representation. So here we're talking about the size and the representation. So we always use var to create and initialize a variable to its 0 value. So when you create variables, you should use var or the shorthand technique. And you use var when you just want to initialize something to its 0 value. So here var person1, p1 of type person, right, is going to create the variable p1 of type person and initialize it to its 0 value, which means name will be empty string and age will be 0. And you can see when I print p1 there on the first line, I get empty string and 0. So that's p1 initialized to its 0 value. So 0 value, the concept of 0 value is that if you don't initialize a variable of a certain type, I'm just trying to think if that happens all the time. If you declare a variable the var, it's going to initialize to its 0 value. That's a better way to say it. So it's there, it doesn't have any value other than the 0 value, and it's ready to use. Always use shorthand notation to initialize a variable. So if I don't want to initialize to the 0 value, but actually set values, I want to use the colon equal. So if I'm going to set my own variables, I'm going to use the shorthand notation. Blank slides. I'm still working on my presentation on type. I've got more to say here. New information. So named versus unnamed. Named, allowed methods, unnamed, anonymous. Type map, map string, map key. Type, type, type. Just let me check this out here for a second, see what I want to say next. All right, so I've got a little bit, I thought my deck was all done. We're out of time anyhow, class is over. But I got a little bit more work to do on my type presentation, so I'll put that together and have that ready for class on Tuesday next week. And yeah, that's it. So that actually kind of worked out pretty well. I ran out of slides right when class ended. And I forgot I hadn't finished that deck. So do you guys have any questions, comments, thoughts? How many people are inspired by the photo blog, the road ahead, what you saw? Good. Yeah. Be cool to make that, right? And then all we got to do is like, you know, a little formatting and we're Instagramming.
That implemented also like an entire account system, registration system and all that. Or maybe it didn't involve registration system, but at least it had a login system.
Yep.
Which I definitely, one of my main goals is to learn all about that kind of stuff.
Cool. So we'll get some of that. All right.